Okay, so this should be video 404. Question 18 tells us that triangle XYZ corresponds to RST. That means that X is congruent with R. Same things happen with Y and Z. When we have similar triangles, the angles are going to be congruent and the sides are going to be proportional. So because they're similar, they have the same shape, and they can only have the same shape if the angles are the same. Otherwise, you know that an obtuse angle is not the same as a right angle, so the angles have to be the same. And they give me that's supposed to be a Z, they give me the measure which is 20. It matches T, they're asking for the value of T, so your answer is 20 degrees. That's it. Here on the 19, I'll go down first. 19, one of the equations in a system of equations is given. Y equals is x plus 18. I'm missing the other one. Y equals, which equation could be the second equation in the system? The key to this question is that the system has no solution. The solution to a system of equations is when the lines cross. Alright, so if they cross at one point, that's the one solution. If it's the same line, infinite many solutions. If the lines don't cross, however, infinite many solutions. If the lines don't cross, it means that the lines are parallel, right? By definition, parallel lines never will touch or cross. So they have no solution. So if I had a y-axis that these two parallel lines went through, so I'm going to draw a vertical line over there, then notice now that we have an x and y axis, this being the x, this being the y axis. Notice that the parallel lines do have the same slope or inclination or slanting or rise over run, but they have different y-intercepts. One is more than the other, so I need to have the same slope, so 6 has to be the same, and then I think it's 22, the one in the choices, but any number that is not 18, as long as it's not 18, then we have the same slope, 6, and different intercept, 18. So this would be 18 on the y-axis, and this would be, I think it's 22. I'll show you what it says. In this system of equations, I'm going to use the value of y, which is in terms of x's, for x plus 1 is the same thing as y, and I'm going to place it here in the second equation. So this will look like 4 times 4x plus 1 is equal to 15x minus 8. Okay, distributing 16x plus 4 equals 15x minus 8. Let's take away 15x. And that gives me 1x, or just x, which is what I'm looking for. But I do have to subtract 4 and write a negative 4 right here. So when I combine negative 8 and negative 4, I get that x is equal to negative 12. Now I need to find y. Using the same equation here that is already solved for y, I need to plug in negative 12 instead of x plus 1. 12 times 4 is 48 negative, so 48 negative plus 1, y is equal to negative 47. Now be careful what the question says, because they're not looking for just x and y. They want to know the value of x minus y. So x is negative 12 minus, because that's in the question, there's a minus sign, and y itself has a negative number, so minus 47, negative times a negative is a positive, so this becomes negative 12 and positive 47. We subtract, and the answer for this is 35. Okay, so now you can pause the video while I erase in case you haven't copied everything. And then I'll show you the choices for 19 and do 20. So as you can see, y equals 6x plus 18. So we cannot use 18 as the y-intercept. We cannot use 12 as the slope. So the only answer is when we add 6 to both sides, and we can rewrite the x's in front of the 22, we're going to get y equals to 6x plus 22, which is what I had before. So you have choice B as having the same slope 6, but different y-intercept. So they're parallel lines. They have no solution. Okay, for number 22, we need to know what, in the quadratic formula, the numbers inside the radical sign is called the discriminant. That's not what the question is, but just so you know. And it's equal to b squared minus 4 times a times c, where a is 5. In this particular equation, that's a. B is 10 and C is 16. So A is 5, B is 10, and C is 16. Now, if the discriminant is greater than 0, that means we have two solutions. If the discriminant is equal to 0, then we have one solution because it will be a perfect square. And if the discriminant is less than 0, meaning we get a negative number out of the discriminant, then we have 0 real solutions because we need imaginary numbers, 0 or no solutions. All right, so all we have to do is plug in. B is 10. You can see here b squared. So that's going to be 10 squared minus 4. Now we have that A is 5. Obviously substituting with parentheses, and finally C is 16. Because it equals to 0, C is a positive 16 right there. So multiplying, squaring 10 is 100, and then we're going to subtract 4 times 5 times 16, which is 320. So 100 minus 320 is negative 220, which is less than 0. When the solution is less than 0, we have no solution or 0 solutions. So 0 doesn't mean that 0 is the solution. It means that we have 0 solutions. How many solutions? How many solutions? 0. 0 solutions. And that's it. So we just use the discriminant to find out. I'm going to erase and scroll. All right, so we're doing good with the timing. Maybe. All right, the easiest question on the SAT is this. What is the area of a rectangle with a length of 34 and a width of 29? So how do we find the area of a rectangle? Length times width. So this is going to be 34 times 29. We have centimeters, which is the same as cm, so the area is going to be in square centimeters. When we multiply 34 times 29, we get 986 square centimeters, and that's the answer. I think we have to see if we can go ahead and skip questions and save some for later and do these fast questions first. That way you have a long time or more time to do the questions that take a little more. Okay, so here is a trick for number 23. Is area. Area is 11,863,808 square yards. But the conversion that we get is 1 linear mile. See, it's not squared. And 1760 yards, you see that's not squared. So that's a linear conversion. So when we have 1 square mile, is a 1 by 1 little square. So 1 mile times 1 mile. 1 times 1 is still 1. That's why we only have 1 little mile. But now the mile is squared. Okay, so now it's going to be the same. I'm not drawing the two areas exactly alike, but they have to be the same, because so right here I have 1, 7, and 60 yards linear, meaning only one side, but for area I need to multiply times the height or the other side. So it's 1760 squared. So 1760 times 1760 is going to give me in square yards 3,104,644. So 3,104, 3,104,000, and then 644. All right, so that's a square mile or so many square yards. If we have 11, 863, 808, what is the area in square miles? Well, this is the same as 1 square mile, the 3. 1 square mile is the 3 million yards. So how many of them will fit into the 11? That's a division problem. So when we divide 11 and we divide it by the 3, 104. Using a calculator, which is now a great news. Calculator is allowed in both sections of the SAT, so you can do that fast, and your calculator should give you 3.83. All right, pause to erase, and then moving right along. Okay, I'm going to come back to 26 later because that's the one that takes a little longer. So 24 is about the formula for a circle. We need to know that the formula for a circle is written as x minus h, where h, positive h, is the center of the circle. Center. Square plus y minus k squared equals the radius squared. Okay, so if we look at all my choices, the radius square is 16. So if the radius square is 16, it follows that the radius itself is the square root of 16. So take the square root, take the square root. So the radius is 4. So we can read the radius is 4. 16 is 4 squared. Now, how do we know what the center is? Right here it says that the circle and the xy plane intersect the y-axis at exactly 1 point. Now think about this. If you're gonna be a circle touching the y-axis, you're always gonna wrap around because you're a circle, so you're gonna have to touch it in 2 spaces normally, regularly, unless let me see, unless only one point is touching the y-axis. And when does that happen? When the circumference, the edge of the circumference, in other words, you have the y-axis is a tangent. That's what it is. So let's draw a vertical tangent to that circle. And right there, you know, is only touching at one point. So that means that I can make a radius parallel to the x-axis, x and y. So my center is right there. I already know that my radius is 4. If the y-axis is a tangent, the distance from here is from 0 to 4 for x. And so the distance from 0 to 4 on the x-axis is the same. It's the same segment from 0 to 4 and from 0 to 4 right there. So it's 4 units long. That means that R is the same as the center of my circle, which is 4. So that's equal to H, which looks like a 4. Alright, so H is positive, so when I go to the formula, I would have to say x minus 4, because that's a positive 4, x minus 4 squared. And the only choice we have, let's look at the choices. That's not even, the only one that says, that has 4 as the center of the circle is choice C. So we don't need to find out what K was or how it was. That's just how high on the y-axis is touching. So the center is going to be 4, 9, but it doesn't matter because only C has the 4 as the value for x for the center of said circle. Okay, so while you finish that, I'm going to erase. You can pause that. After I erase, I'm going to go to 25. Okay, so we have two triangles ABC, and they correspond to DEF. That means that angle A is the same as angle D. They write it in order for a reason. So the middle angle, they're going to be corresponding, and then DEF. Okay, so what do we have? B and E, as you see, they measure 27 degrees. So B and E is 27 degrees. And then C and F is 41 degrees. Because all triangles have three angles that add up to 180, that means that both A and D have to be 112 degrees. So when we add them, we get 180. You can check that. So we have angles that are congruent. However, we can have two angles that are the same size, like in that case, my red triangle with my blue triangle. I put it on top of each other, but they have the same angles and the same size. This is 112. Looks like a right triangle, but it's 112. Anyway, they can have the same angles, but one can be twice as big, right? So we don't know if they're congruent or similar unless we know the value of the length of the sides in both triangles. So the measure of angle A could tell us that the angles are either congruent or similar, and we need to find out if they are congruent So having all the same angles doesn't tell us that whether they're congruent. They might be, but they might be similar. I already said that similar shapes have to have congruent angles. Okay, so the measure of angle A doesn't help. The length of side AB, that would be nice, but that only gives me one of the triangle sides, AB. So I don't know what DE is. Could be twice as big or half as big. So I need more information. So if I have the length of BC, if I have the length of BC, and which is in one triangle, and I also have the length of EF, then that's all I need to find out if the triangles are congruent or similar. If they are the same, like in my drawing, then BC would be whatever number we want it to be for now. BC would be 5 for the blue, and it will be equal to 5 in the red units of length. So they will be congruent. If they're not, then they will be similar. If it was 5 and 10, then one is twice as big, so it would be a proportionality of 2. So that's all there is to that. Your answer is C. You need to compare angles and the length of sides in both triangles to see whether they're only similar or also congruent. Okay, and then we have 27. And back to 26 after 27. 27 is a right triangle. Remember the Pythagorean theorem. You don't have to remember the word. Just remember that c squared is equal to what? To a squared plus b squared. All right, and then we can solve for c. So we have a right triangle. Check, check. So we're using the Pythagorean theorem. Check and check. And we have legs. Legs are A and B because they make the angle. And the hypotenuse is C because it's the side opposite the angle. So we have 21 and 24. So if we are using this Pythagorean theorem, and we are, and so we know that C squared is going to be equal to each leg squared and added. So we have 21 and 24. So 24 squared plus 21 squared. Using a calculator, notice that I'm going up in, because of the space, I'm going up in my writing of the problem solving. So c squared is equal to 576 and 441. 24 squared is 576 and 21 squared is 441. Adding those quantities together, we get that c squared is equal to 1017. However, they want the hypotenuse to be somehow simplified so that a 3 comes out of the radical. And we just need to find out what number it is. So what if we had a radical, right? Let's say that we had 18 as an example. If we had 18 in here, I can substitute the 18 and factor it. Instead of 18, I can write 9 times 2. Because 9 times 2 is 18. So 9 times 2. Why would I do that? So I can split the radical. The square root of 9 times the square root of 2. And the square root of 9 is 3, because 3 times 3 is 9. So in this case, the square root of 18 is equal to 3 radical 2. Okay, so we need the same 3 here. That means that we need to divide 1017 and divide it by 9. Because now, okay, so that was like my side example as to why we get a 3 outside the radical. So now we have to take the square root of both sides, and that's how we get c out. That's what we solve for C. That's going to be equal to the square root of 1017, which is going to be equal to 9 times dividing 117. It was easy to divide 18 by 9 and we get 2, but when we have 1017, notice that 1 plus 1 is 2 plus 7 is 9. So 9 goes into 1017 perfectly, and it's going to go in 113 times. So 9 times 113, based on what I did before, C is equal to the square root of 9 times the square root of 113. The square root of 9 is 3. So C is equal to 3 radical 113. If I have 3 radical D, compare, C is equal to 3. C is the hypotenuse. Radical D, that tells you that D is the same as 113. So D equals 113. The only thing you were missing is the calculator. So now pause. So when I erase, you still have the video paused. And now the last question. Let's read the question first. Two data sets of 23 integers. So we have whole numbers, right? Because it's on the right side of the y-axis. Are summarized in the histogram shown. For each of the histograms, the first interval represents the frequency of integers greater than or equal to 10 but less than 20. So from 10 to 19, from 20 to 29, and so on. What is the smallest possible difference? What is the smallest possible difference between the mean of data set A and the mean of data set B? Okay, so for that, we need to remember that in a histogram, it tells us how many numbers we have here between 20 and 29. We have 3 numbers that are between 20 and 29, but it doesn't tell us what the actual numbers are. It could have been 24, 26, 28, or it could have been 21, 23, 25. We don't know the exact data. This is a histogram that tells us certain things about the data, but not every single data point. So we want to subtract the mean of data set A minus the mean of data set B in a way that the difference is the smallest. If you notice here, data set A has data after 50 and nothing for the 0 right here. There's nothing here, and we have data up to 59 right there, up to 59. Whereas data set B doesn't have anything from 50 to 59. So in order to get the smallest difference, we need to bootstrap data set B, and we need to lower down the values of data set A. We need to lower them. So if this is from 20 to 29, and this is also from 20 to 29, I want the smallest difference. So when I subtract, you know, if I do 29 minus 20, that's 9. But if I do 20 here minus 19 from the other group, then the difference will be 1. So let's just find the mean. What this means is that I have 3 values that we're going to use 20 for data set A. We need to use the lower values of each bar on the histogram. So I have 3. This is a 4. You can see that's a 4. Then we have 7. So we have 3 here. Let me erase that. So we have three numbers there, and we have 4 there, and we have 7 there, and we have 9 numbers in there. And the same thing happens here, is 3, 4, 7, and 9, which when we add, we get 23, and that's exactly what we're being told. They are 23 integers each. So remember that when we add all the values, we have to divide by 23. So for data set A, we're going to use 3 values from the first bar, which we're going to leave as 20, not 29, because we want the smallest difference. So we're going to do 3 times 20 plus 4 times 30 plus 7 times 40 plus 9 times 50. All right. And then for data set B, we're going to use the highest possible value so that the difference is the smallest between the two sets. So we're going to do from this bar, we're going to use 19, which is the highest that can fit in this bar. So it's going to be 3 times 19 plus 4 times 29 plus 7 times 39 plus 9 times 49. That way you see the difference between the green and the blue is as minimum as possible. So continue to find the average of A. We find that when we multiply and add the values of A are equal to 910, and then we have to divide that by the 23, divided by 23. And then the values of B, when we add 3 times 19 plus 4 times 29, etc., the values of B are equal to 887 divided by 23. Okay, so here we could find the average and then subtract the two averages, right? Or we can use the distributive property of division, and instead of doing all that, we can say that if we use the distributive property of division, this is 910 minus, because it's a difference, right? Difference is to subtract. Minus 887, and the distributive property of division says it's going to be the same thing as doing it individually, divided by 23. Now here's what's neat. 910 minus 887 is 23. And we know that 23 divided by 23 is 1. So the smallest possible difference within those integers will be in the means. The mean will be different by just 1. I didn't calculate what the mean is, but I know that the difference between them is 1. So all of that work just to get the right answer, but it's worth it. B1 is your answer. Thank you very much, and good luck taking your SAT.